was that? Alright. Today, we are going to do a review of factoring. We need factoring for what we're going to do next, okay, dealing with rational functions. So, we're going to review factoring to make sure that we have this down. We're going to use it for the rest of the chapter. So, we're going to look at a few different scenarios, okay, the first of which we have two terms here. Does anybody remember anything about factoring something that looks like this? What it's called, how we do it, anything about something like this? We're going to have two sets of parentheses, yeah. Right. Well, so here we're just factoring. So that's the answer. Right, so Gracie's right. Right? If we have something that looks like this, and this is called a difference of squares, right? Okay, what that means is difference means subtracting, and squares means perfect squares. So if we're subtracting two perfect squares, that is the case here, right? N squared is obviously a perfect square, and 9 is a perfect square. So whenever we're factoring something like that, I write it as the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Right? So the first thing we have to do is actually check to make sure that we have a difference of squares. So the difference part, I'm subtracting. Right? Now are each of these perfect squares? Is b squared a perfect square? Yeah. Is 1 a perfect square? Gotten that same answer all day. Yeah. 1 is a perfect square. What's the square root of 1? 1. It's a whole number. So 1 is a perfect square. Right? So this is a difference of squares. How would it factor? Right. B minus 1, B plus 1. Right? Now these next two also look like they have the potential to be difference of squares, right? But in these ones, I have an a value, a coefficient in front of my x term. So first, we want to check to see if these even work. So is 16n squared a perfect square? Yeah. 16 is, n squared is, how about 9? Yeah. And I'm subtracting, so this will work. So what are my two factors going to look like?
4.
Square root of each piece. So do the last one, these difference of squares real quick here. We get 2x minus 3 and 2x plus 3. So one common question I've gotten all day is that, does it matter what order I write these in? No, it does not matter. Okay, I could have had the 2x plus 3 first and then the 2x minus 3. That does not matter. All right. Questions about difference of squares? All right, let's take a look at the next set here. These all have 3 terms in them. So they're obviously not going to be difference of squares. All of these, we are going to be able to x factor. How do we x factor? Well, then I would pay attention. All right. Up here, in the top of the x, we put a times c. What that means is take the number in front of the squared term times the constant. So just the first number times the last number. So 1 times 80. The 80 up top. Yeah. And then on the bottom, we put our b term, which is negative 18. So write down what we did here. So this was a times c. And then down here was our b term. So So now, the goal is to find two numbers that multiply to positive 80 that add to negative 18. So, I mean, yeah, we just want to get out the calculator and start figuring out the factors of 8. We can just start listing them over here until we get ones that look like they might work. Right? So obviously we have 1 times 80. There's no way to add or subtract those to get negative 18. And 2 times 40, still nothing. Right? 3 does not go into 80. 4 does. We would have 4 times 20. Still 4 plus 20, or minus 20, 20 minus 4. There's nothing.
How did I not know that?
Let's see. So 5 goes in evenly. 5 times 16. Still, I can't add or subtract those to get 18, negative 18. 6 does not go in evenly. 7 does not go in evenly. We get 8 times 10.
Not bad.
Looks like that might be the winner. So 8 and 10. 8 plus 10 is positive 18, though.
Are they both negative?
They're both going to be negative, right? Because if I multiply a negative times a negative, I'll get positive 80, and then add them together, we would get negative 18. Now, my A value on all of these examples in the front is 1, meaning the number in front of the squared term is 1. If A is equal to 1, the number out in front is 1. From this point, we can go straight to factors. And what that means is this negative 8 and negative 10 will be part of my answer. My answer is just n minus 8 and n minus 10. Those are my two factors. I'm done. Okay? That's if A is equal to 1. And then all of these examples on the front, A is equal to 1. Okay, we'll look at examples on the back where A is not equal to 1, and we'll have to do something a little bit different. But here, we're just x factoring, finding these two values that multiply to A, multiply to A times C, that add to B, and those are our factors. Okay? Questions? Do we want to do one more together, or do you just want to try it? Alright, well, looks like everybody's jumping into it. So go ahead and try up through 10. Okay, the rest of the front here. Alright, these should be our answers here for 5 through 10. Check your answers up here, and then are there any that we want to take a look at in any more detail?
So like number 8, you said it doesn't matter if it's backwards or...
So yeah, we could have x plus 10 and x minus, or x minus 10 and x plus 3.
I have it right, I just put like x minus 10 and x plus 3.
Yeah, that's fine. Yeah, it does not matter the order that you put the factors in. I mean, the signs matter.
Yeah, I just... Yeah.
Right. Any other questions?
No. I'm confused on 7.
7? Alright, let's take a look at 7.
No, because the 9's supposed to go up top, right?
Yeah. Yep, so we would have positive 9 here and then negative 10 down here. So we want two numbers that multiply to positive 9 that add to negative 10.
10 instead of 9.
Yeah, so it'd be negative 1 and negative 9. Right? Any other questions?
No.
Alright, let's flip over to the back then. On the back, everything that we see, our A value, meaning the number in front of the square term, is not 1. So we're going to have to do something a little bit different. The first few steps are still the same. Okay? I'm still going to x factor, meaning I'm going to take my A times my C. That's what goes up top. So 2 times 54. So that's 108 up top. Then my B value, 21, goes in the bottom. And now I want to find two numbers that multiply to 108 and add to 21. And that's not immediately obvious to me. So let's list out the factors of 108. So 1 times 108, 2 times 54, still nothing. Right? 3 times 36, still no. 4 times 27, close, but I don't see any way to get 21 out of that. 5, no. 6, no. 7, 8, 9 and 12?
Yeah.
Yeah, 9 plus 12 is going to get me 21, right? So now, since my A value is not 1, I cannot go straight to factors. What we have to do, if my A value is not 1, is factor by grouping. So what that means, I'm going to take my two numbers, my 9 and my 12, and I'm going to split this 21b up into 9b and 12b. So that's going to look like this. This 2b squared comes down. Then I'll have plus 9b plus 12b. So this 21b I just split up into 9b and 12b. Okay, and then the 54 comes down as well. So now I want to group the first two terms and group the second two terms. So I'm grouping like this. And now I'm going to look for a GCF, greatest common factor, in the first two terms and then separately in the second two terms. So if I'm looking at 2b squared and 9b, I first want to look at the numbers, the 2 and the 9. Is there a common factor between 2 and 9? Are they both divisible by anything that's the same? No. Right? Then I want to look to my variables. Here I've got b times b. Here I've got b. I can take a b out of both of them. Right? When I do that, what am I left with?
2b plus
2b plus 9. Right? I want to go through the same process then with my second set of terms, the 12b plus 54. So I want to look at my numbers, 12 and 54. And I want to look to see what the largest number that divides evenly into both of them is. So 2 goes into both of them. What about anything
6.
bigger? 6. Yeah, 6 goes into both of them. I think 6 is going to be our greatest common factor. So if I factor out a 6, what am I left with here? 2b. And if I take out a 6, 9. Now at this stage, these two things better be exactly the same. They are, right? We got 2b plus 9 for both of those pieces. Now, what we're going to do is factor a 2b plus 9 out of both of these things. And what I'm just left with then is b plus 6. Okay? So from here to here, okay, my answer becomes b plus 6 is one of my factors, and then 2b plus 9 is my other factor. And that's my answer. Okay, that's the factor form of this quadratic. Okay? Questions? All right, let's do one more of these together, because these ones are a little bit trickier. They're lengthier, yeah. All right, so let's make my x. So a times c would be negative 72, and then my b value is 1. So I want two numbers that multiply to negative 72 and add to positive 1. Okay, so start listing out the factors. 1 and 72, 2 and 36, 3 and 24, 4 and 18. I'm not getting anything close to adding or subtracting to 1 yet. 5 doesn't go in evenly. 6 does. 7 does not. Ooh, that might be the winner right there. 8 and 9. Now, if this number is negative, okay, if my a times c is negative, that means one of these two values will have to be negative, right? Because the only way for me to get a negative number when multiplying is a negative times a positive. Right? A negative times a negative would get me a positive. And a positive times a positive would obviously get me a positive. So if this number is negative, one of these is going to have to be negative. So if I have it narrowed down to 8 and 9, which one of these should be negative so that when I add them, I get positive 1? 8. Right? Negative 8, positive 9 then are my two numbers. So what I'm going to do is split this x into negative 8x plus 9x. So this will become 2x squared minus 8x plus 9x minus 36. Okay. Now, we factor by grouping. So, group the first two, group the second two, and look for the GCF. So what is my GCF for the first two terms? 2x squared minus 8x. What's my GCF for the first two terms? 2x. So if I take out a 2x, what am I left with? X minus 4. Right, so now, the second two terms, what will my GCF be? 9. And what am I left with? X minus 4. Good. So at this stage, I have the same factor, x minus 4 in both pieces, so we're good. So what's my final answer? There you go. All right. Questions on these ones? All right, then you guys take a couple of minutes and try the next two. All right. Okay. As you're finishing up these couple, check your answers up here. See how you did. Now we can, if there are questions, pick out one or two of them to go over in more detail. What?
Hello? Go ahead.
All right, so how did we do? Feel pretty good? Questions? Any that we want to go over in more detail? It didn't sound good.
No, I just messed the signs up.
Which one?
No, it's fine.
All right.
I only messed that one up.
Okay. So no questions on these then?
No.
All right. Then let's take a look at the last set, 14 through 20 here. All right, 17 through 20, sorry. 17 through 20. On these ones, there's one extra thing. And technically, we should be looking for this first on every factoring problem that we do. I just put this set last because I wanted to review factoring so that we could complete problems like this. So does anybody remember the very first thing you should look for on all factoring problems? A GCF, right? We want to look for a greatest common factor before we start doing anything. So in this first example, 4p squared minus 24p plus 20, is there a GCF? Is there a common factor that I can divide into all three of those terms? 4. And I can take a 4 out of all. So what am I left with then? Exactly. So now I just want to x factor this, the p squared minus 6p plus 5. So make my x, a, which is 1 now, times c of 5. So 1 times 5 goes to the top. And then in the bottom, take my b of negative 6. So I want two numbers that multiply to positive 5 and add to negative 6. What do we got?
Oh, never mind. How do you multiply negative by 5? Negative 5, negative 1.
right? They should both be negative. Okay, because -5 plus -1 is -6. -5 times -1 is +5. So since my a value was 1, I can go straight to factors here, right? So I can just make this p minus 5 and p minus 1. And that's it. That's my answer. Questions on that? Do we want to do another one? All right. So on this one, I want to look for a number and potentially a variable that I can take out of all three terms, right? Well, all of these are divisible by 2. And they all also have an r. I can take an r out of each of these terms as well. So my GCF ends up being 2r. Then, what I'm left with, so I took out a 2, so my coefficient here just becomes 1. And I took out an r, so now I'm just left with r squared. Here, -6 divided by 2 is -3. If I had r squared and I took out an r, I'm left with 1r. Here, I would just be left with 2. Okay, so now, again, I'm looking for two numbers that multiply to +2 that add to -3. So that would be -2 and -1. So we end up with 2r times r minus 2 times r minus 1. Alright. You guys try the last two and then we're done.
Wait, do we have to put the 2r on the outside?
Yes. Yes, that would be part of the answer. That would be part of the factorization.
So my data cut it. No. Just a little bit.
If I get them tomorrow, it'll still be full credit.
Quiz acting like she's going to turn it in. She's saying, I'm doing my work. Oh my god. we must that was the end of it. Yeah, that was the end of it. My manager, they always try to call me into work as if I'm actually going to come in.